So, a trench wall, okay, with sandbags, although, you know, probably in a trench wall, you probably do not have sandbags, but have something like wood or mud. Okay, I just felt that it's going to be more interesting if we just did something we haven't done before in the channel. Okay, the reason for this is basically I wanted to, except of doing something that looks nice, it was like, I wanted to do a general introduction into the FX map, and what we're going to use the FX map for is to place these branches on a variable position based on how many you have. So if you want to have 5 or 10 or how many branches you want, we will use the FX map to place all of them into the range of our actual substance. And we're also going to randomly select which one we want to place based on how many patterns we add on our FX map. Now, because it's randomly, then that means there is a chance that you will get duplicates, and there's also a chance that all of your branches are going to be duplicate and stuff like that. And that's the unrendered one. Now, okay, again, as with all substances in the channel, you can download them. If you go into my pattern page, you will find a link in the description below, and you can download them from over here. You do not have to pledge to download, but of course feel free to do so that I can keep making all these videos. Now, back into Substance Designer, we're going to see first our wooden branches. To make the branch, what is a branch? Is basically a crooked line. We're going to start with a gradient linear 2 because we want the gradation we have on the edges. We're going to use transformation to D, disable the tiling either to this one or transformation to D. Okay, it doesn't matter. Then we're going to use a directional warp, and for the intensity input we're going to use a gradient map, which we're going to create from a gradient linear 1, and depending on the positions we have placed on over here onto our gradient map, we're going to make our basically crook align, and also depending on the warp angle. Okay, if your curve over here is not that smooth, then you simply need to come over here and click the interpolate. Now I disable it, and you can see that it looks more pointy corners, but we want to have smooth corners. Now, of course, this depends a lot on the entries you have. If you have too close different values to each other, then that means you're still going to get pointy points. Now, we're going to do this 3 times, as you can see, different warp angles. Usually you want to have something like that looks more towards the edges, either one side or the other, and we want to do that. I think we should also interpolate this one. Okay, we want to do that because if we do it upwards, then it's not gonna look, you can see, because it tries to warp on 90 degrees, it doesn't really do anything. Okay, so we're going to keep it like that. So we have our 3 patterns, and we want to randomly select each one and place them on a fixed position, or not a fixed position, a variable position based on the amount we select. And we want to have all our branches, so if we select 10 branches, we want to have all 10 inside our picture. So we're going to utilize an FX map to do that. Before we use and see the FX map, we need to come into our input parameters and click this little plus sign, and we're going to add a parameter. We're going to use an integer and write the identifier, something you can remember. I add an underscore first so that I know it's one of my variables. Okay, even though we're not going to see, we're only going to use only once. It's a nice habit to have, so you can, if you have a habit that scales fine, that can scale without a problem, then that means it's a good habit. Okay, and if you see other variables which we're going to see that have a dollar sign, these are the default Substance Designer variables. Now, basically what we need to know about a variable is the integer. You probably do not care what these are internally. Okay, I can tell you a boolean is a variable that is stored in memory, with just one bit. Yeah, I'm not going to bother explaining all the rest and how an integer or float is saved, because most of you, I suppose, you are artists, so you don't even care about that. Okay, we're going to use integers in this case. Integers are basically whole numbers. Floats are basically numbers with decimals. Okay, as simple as that. And because we're going to do a subdivision, obviously you cannot subdivide with 0. So we're going to set the minimum to 1, and maximum you can have 10, you can have as much as you want. However, do keep in mind that when you as many as branches you add, we're also pushing back the background image. Okay, because it makes a nice effect, as you can see over here with our sandbags. So if you add a lot more, then that means you're either going to reach a position where there's not going to be any background, or it's going to be looking pretty flat. Okay, and I'm going to leave the default to 3. And yeah, now we're ready to see the FX map. This is a copy paste. This is a copy paste of this FX map because we're going to see a lot of changes, and we do not care about updating the graph every time we do a small thing. So create the FX map, add the grayscale. Okay, this is important to click the grayscale, and edit FX map. You can also do it if you double click over here, you will also get the same design. Now, basically, an FX map is still a visual node system, but you only have 3 nodes: iterate, switch, quadrant. Switch is basically switching from one branch of your tree to the other, and iterate, we run it again, so you probably only won once. And what I mean run it again is the logic you have is going to run it again, so it's like going to pasting another image on top of the image you have. However, because we can program stuff and it's all procedural, okay, we can add different behavior, so the next time it runs, it's going to do something different. In our case, I have an iteration depending on the amount of branches we have, and we can select. In my case, it's 3, and I say 3 because this one is tiled on the other edge. So okay, so there's that. So it's only 3. So the 3 unique ones are these 3. So the first time, what it does is takes the input image, it randomly selects one of those 3, and it puts it on the position we have over here. The next time it's going to run, it's going to get the starting position, because think of it like this. Okay, this is 0, 1, 2, and so on and so on. Okay, 3, all that. What we can do is basically take the position we have over here, and the next time we can access the iteration value. So we can actually access on which time you're running the code or the logic, or whatever you want to call it. So what we can have is find the distance we want to place each one apart, and each time we do it, take this distance, so let's say it's 0.2, and multiply it by the iteration amount. So what this effectively will do is, it says it's the first iteration, it's going to multiply by 0.2. Okay, obviously it's going to return you 0 on the x. Okay, this is an x value, the x-axis, and yeah, this is actually -1, and this is 1, and 0, 0 is the center. But for right now, just think of it like this. When we go inside the actual graph, we're going to, we're going to go more into depth. Okay, so this is 0. The second iteration is going to be multiplied by, again, 0.2. So it's going to give you 0.2 position. The third iteration, because the iteration starts from 0, obviously, okay, it's going to be 0.4 and so on. Now, how we get the 0.2? Okay, it's an arbitrary number at this point. Okay, but basically how we get the 0.2 is by doing a simple math operation. Okay, so you have a distance of 2. So if this is 1, if this is 0, this will be 2. So this is your distance. Not exactly though, again, because this is -1 and 1, but the whole distance we're going to be placing our branches will be 2. Okay, because even if it starts from -1, it doesn't matter at this point. And okay, simple math, you've done this in school. If you have in a distance of 2, if you want to add 5 branches, then you do a subdivision and you get the amount of each one is need to be placed, so all of them will fit inside your script. Okay, this is the higher logic how this is going to work. Now let's see it how it's actually going to work. And yeah, again, before we actually see that, let's see the nodes. The iterate runs the logic anytime you have over here, and the quadrant is what places your input images on the actual what actually outputs it. So the quadrant on the first depth is what you see over here. It's all this. If I was iterating only one time, or if I delete this, so it's basically only one, you're only going to see this and this, because this is tiled from this one. Okay, if I add another quadrant, it's going to subdivide this, and it's going to subdivide it into the first quadrant, and you get to 4 more quadrants. Okay, if I add this into not a square, let's add something. Let's add an input image. Okay, if I keep adding quadrants, or let's do a Ctrl-C, Ctrl-V, it's going to keep subdividing and keep subdividing, and each time, as you can see on the icon over here, and each time you add more depth, it's going to keep subdividing and subdividing that quadrant and that quadrant. However, in our case, we only want the very first depth, because we know our branches is going to reach from one edge of the graph to the or the image to the other. So we're going to only work with this one. Okay, so let's hook the first thing that it's pretty easy. Go to the iterations, make an empty function, click this, and you are over here. And here we have our input parameter we set from over here. Okay, it's this one, and here's where we need to remember the actual identifier name, which is the variable name basically. Okay, so we have underscore branches, so that means it will run the fx map as many as the branches we want. Okay, so we want 3 branches, it's going to run the logic and it's going to place 3 branches. If we only want 1 branch, it's going to add on the very first one. Now if we didn't want any branches, then I don't know if this is going to work, because we do a subdivision with 0, and actually let's test it, and let's see. So yeah, it does work. So there's probably internally something that can fix that. So this is actually not even that bad. Okay, So yeah, use that to your advantage. Usually when you are writing code, yeah, you kind of are careful not subdividing with 0, otherwise you get some errors. Anyway, that's the pros you have when you are visual scripting. Now we have, I reiterate, we've seen this, we have our quadrant. Before we see the actual pattern offset though, we're going to go on the input image index and we're going to create a function. So what this does, it's going to get a constant float. It's going to give us a random number between 0 and the maximum number we're going to pass. In this case, this is going to be 5. It's going to cast it as an integer. So it's going to round it onto an integer because a float is a decimal point. It has decimals, and we cannot have on our inputs, you cannot have 1 from one image and half of the other input. Okay, it doesn't make any sense. So what it's going to do is going to cast it as an integer, as a whole number basically. The only thing you need to take into account in this is whatever you set over here, it's basically the percentage of how many chances one of these branches have to actually show on the final output. Okay, however, because it's the way internally works, because somebody has written some fail-safes on a lower level, if you have more floats than more numbers than the actual inputs you have over here, then it's always going to it's clamped to go towards the highest or the last input image you have. So what this means in plain English, then that means if you have 10 inputs and 10, so this is 10, okay, then that means every pattern has 10% chances of showing up. Okay, if you have 3 inputs and 10 positions, then that means the last input, so the third one, will have 70% chances. Okay, because everything over 3, it's going to be rounded to back to 3. Okay, it's clamped back to 3. Okay, it's simple enough. Just keep that in mind. It's not a problem. You can do a lot of stuff with this, obviously. Okay, but just keep that in mind. If you have more inputs, if you have if this is less than the inputs you have, then that means everything over on top of that is not going to do anything. Okay, very simple. We float and we cast it as an integer, and we have a randomly placed we have a random input. We assign, every time we run the logic, we assign randomly one of these branches. Okay, if I change the random seed, you can see that it randomly assigns again. Okay, if you want to have equal chances, then simply set this the same amount as your branches or as your input images. Okay, let's go to the heavy stuff and let's see the pattern offset. So don't be afraid, it's really easy. What we need to know, the very center of the image is 0. Okay, and that's really crooked. Every image is usually like this. You have your y-axis and you have your x-axis. The very center where they meet is 0, 0. Okay, because y is 0 and x is 0. Okay, really simple. So what this gives us is the upper edge of this one is 1 and the lower edge will be -1. Same with the x, -1 and +1. So everything you do over here is depends basically on your depends it's pretty much vector math at this point and on. Okay, and now keep in mind that in Substance Designer at least it's like this. In other cases and in other environments this might differentiate a little bit, but usually I think it's pretty much what you're going to see most of the time. Okay, and I say most of the time because you never know what crazy programmers there are out there, and there are a lot. Now, where we can use this into our own, onto a graph we have over here. We know that the very first branch we're going to have is going to be placed over here. So what is this position is -1. Okay, so this is going to be this one. Oops. So this is going to be this constant float value. So this is our start or our origin, or call it whatever you want to have. So what we need to do is we have our start, which pretty much is constant. We're always going to want to have a start. Okay, somewhere to start from. So we now need to keep adding and keep adding. First, of course, we need to find the distance each branch needs to have from each other. To do that, we use, again, get integer. You need to write it. It's not going to show over here, I think. If it doesn't show over here, then simply copy paste the branches. Okay, I don't remember at this point. Let's see. Although because I've already written it, it might be over here. If it doesn't, then simply write it. I think, yeah, it will show. Okay, so what we do over here, obviously this is an integer, and we need to subdivide with a float. So we need to cast it as a float. Yeah, in other environments, it doesn't matter if you can subdivide a float with an integer. However, the return value is going to be a float. Okay, so it actually makes sense that they will cast it as that you have to cast it as a float first. Anyway, it doesn't matter. Okay, just keep in mind that we get our integer, we turn it into a float, we subdivide it by 2. The 2 over here is the maximum distance they can, let's say, travel, or the maximum distance they can be placed. Okay, where that 2 comes from, -1 plus 1. Okay, we obviously do not want to do anything with the negative. So if you were from -1 to 1, to go from -1 to 1, you need to move 2 steps. Okay, so this is the distance we need. We subdivide by 2, and this will return us the position, basically the distance between each branch. So if you subdivide 2 by 10, you get 0.2. So each branch, if you want to have 10 branches, it's going to subdivide into, it's going to place them by 0.2 distance. Okay, to actually see this, if you want to have a constant value like this, it's going to, oops, yeah, we want the iteration number like that. If we change this, the multiplication, it's always going to be placing them at 0.3 distance, and so on and so on. The reason why we're not adding just a constant value over here is that it won't matter as many as branches we want to add over here, they will keep adding towards the side. However, because the pattern actually tiles, you're going to start seeing them the other side, and the other side, and the other side, and you get something that it's not really what we want. Okay, so that's why we do not add constant value. Obviously there is cases where you can actually use that, so use also that info to your advantage for future references. Okay, so we have this, and as we said before, we need to know, and we need to get the number of iteration it actually runs. So the first time it's going to run this logic, Again, it's going to go and say, obviously the first time is 0. Okay, that's how it usually is on all environments. Usually, again, there's a lot of weird stuff out there. And yeah, it's going to come with 0, it's going to multiply with, that's supposed to be a multiplication, with, let's say, 0.2, or whatever this returns us. Okay, and it's going to, of course, get 0. The second time it's going to get 0.2. The third time it's going to get 0.4. Okay, and so on and so on. Okay, that is if the distance, if this was 0.2. Okay, doesn't mean that these are exactly at 0.2 and towards from each other. Okay, so this is how it works, and this is how you will do it when if you were scripting something. Obviously, if you have a scripting background, you can do a lot more stuff easier than what you did before. Okay, however, because we do not start from 0, we start from -1, we cannot directly take this value we have over here and place it, because what it will do is it will take it directly from 0, and this line is because it makes it tiles. Okay, so if you do not tile this, then this one will be on the other side. And yeah, let me think of a way to showcase this. Let's go to the trans wall and let's change the branch amount. Okay, you can see that it starts tiling on the other edge, although yeah, because we keep adding, it's not really entirely wrong. You can do it like this, now that we can see it, but yeah, there's no, from what I can see, it can work just fine. So let's set this back to 3 since it tiles, but let's keep it just to show the other way. Let's leave it like this. Okay, if you start adding on the -1, then it means it's going to placing them like this, and it's not going to tile them. Okay, of course it might be the opposite way, or starting from the center. Okay, then do it the way I said before. Now what we do with this value, which is basically just a simple number at this point, we need to basically assign it as a position. To assign it into a position, we need to use a getFloat2 at this point, because the position of a pixel, of an image, or of anything like this is stored as a float2. So because you have an x you have a y and an x value, and because there's also rotations and there's also depth on some cases, okay, you might see stuff like this. Color is I think it's a float 3. Color is a float 3, but or it might be a float 4, I don't know. Anyway, in our case, we need the position is stored as a float 2, so that means y and x. Okay, if we get with this to use one of these position, or to use a variable we have over here, we need to use a swizzle float, and with swizzle float you can basically select one of these. Let's say it to z. You can see that z is 0 and w is also 0 because it's not used. If we change this to y, then it's going to it's going to do it vertically instead of horizontal, even though you cannot really see the difference, I believe, in this one. Yeah, you cannot see the difference because either one you select, it won't matter. And now that I think of it, there's no real reason to do, or yeah, there is, I guess. Yeah, so you can see that little changes it does. Probably because this one is stored as 1 and 1, I believe, or probably does anything over here. Okay, the switched float, it won't matter because on the end we still assign it as on the X position. Okay, and on the Y we simply pass the 0. If I keep adding into the Y, you can see that it starts going, and here's where the pattern ends, and it starts going vertically. Okay, so let's leave it to 0. Okay, it's yeah, I hope it wasn't too hard. Okay, it's not really anything, you know, it's not really that hard. It's simply math, to be honest. It's just, you know, learning a little bit about the API and how things work. If you know scripting or just basic math at this point, it's simply about learning the API of its environment to do it. So we create an X position in our case, and we simply cast it again as a float 2, and we output it as a node because the offset is using a float 2. And here's another thing you can actually do also. So, for example, now this is more of an advanced, yeah, it's not that advanced, to be honest. But let's say if you wanted to add something over here, you didn't like that it's always a fixed position, and you always wanted to add a little bit of more randomness, so it's not always the same distance to each other. Some might actually be closer to one another, and or one another, well, you know, and so on and so on. So what you can do, okay, this is one way. There's obviously a lot of ways. Let's get a number, let's get a float or a constant float. We're going to name this up to 100, and we're going to get a random float. So we're going to get a float from 0 up to 100. Okay, we're going to do an if else, and this will give us a yeah, you know, a no or a yes, and you will see, oops, kind of a bad timing. Anyway, I paid my fee. So yeah, as I was saying, this will give us a yes or a no, and you will see what the yes or a no is going to, oops, this, and yeah, we need to set it as higher or greater, or you can set greater or equal, it won't matter. Okay, and you need to pass another constant float, or you know, whatever you want to have. So let's set this as 50. So it's going to be 50% chances of a yes or a no. Okay, now if it's yes or a no, then we're going to use a float. We're going to assign this as 1, and we're going to get this, negate this, or you can just copy paste and do a -1, but let's do it the fancy way. Let's do this and assign it to either each one you want. Okay, it won't matter. In this case, it won't matter. In other case, it might matter. So what this will give us is, based on a 50% chances, will give us either 1 or -1. Now, where we can use this is if we get a float, and it's a constant float, of course, and let's say the maximum offset we want to have So the maximum offset of the sender where we are placing the branch, okay, they basically a threshold. So let's see, let's do it something like 0.0, let's do it something like 0.1, 0.1. Okay, we're going to get a random number between 0 and the maximum threshold we have, our constant float. Okay, now what we're going to do with this is we're going to do a multiplication between this and whatever returns out of our if statement. So it's going to have, based on 50% chances, if it's going to apply it as a negative or as a positive value. So what we're going to do is we're going to simply add, and we're going to add our previous value, and we're going to then multiply that into our export. So what this did, let's also raise this one. Okay, you can see that it doesn't just places the values, let's add something else. It doesn't just places the branches into a fixed position, it also adds another random offset, just a little bit, you know, although 0.3 it might be a little bit too much. Let's do 0.8. It also adds a little bit more onto that position, to that position, so it's not really that fixed. Okay, so if you take this and measure it, you will see that it has the, let's say, 0.2, because it's easier to remember. Okay, it has the 0.2 value, plus if this returned positive, this probably returned negative, obviously, because it's lower than this one. Okay, there's also a chance this will be 0, so it will not add anything. Okay, it's also, it depends on whatever the offset is this. It's either going to be the minimum or it's either going to be the maximum. Okay, so with this, and it's going to add either minus, let's say minus 0.08, although this is horrible. Okay, or a positive 0.08. Obviously, when you add a positive number to a negative, then it's a subtraction, it's not an addition. Okay, so this is the general way of a general introduction to visual scripting, you can say. Okay, we can do some more advanced stuff later. So, okay, you can do a lot of stuff with this. This is pretty much like the pixel processor, just the pixel processor, or I think this also has, I think this is also the pixel processor, the same thing, but it's inside the FX map. So, you know, it's basically the visual scripting way the Substance has. So, okay, this is how you pretty much set the branches, and that's basically the meat of this video is. So what we managed to do in the sort of amount of time of 40 minutes is pretty much cover how you can randomly place one input and then assign it on a fixed position on the pattern, you know, on how many branches you want to add. Okay, let's quickly go and see all the others and see how we can texture this and keep adding a lot more stuff. The stuff we covered, it might have been boring, but trust me, they are really powerful. We can do a lot of stuff with this, and especially because it won't limit us into nodes that we have over here. Okay, you can do incredible stuff with this, and we're probably going to see a lot of stuff in the future. So let's go back over here. Again, what we do is we get, with the FX map, we place our branches, and depending on the resolution you are going to output it, you either want to use one of these. Okay, if you go into higher resolutions, you want to, because I think this is a little bit resolution dependent, although yeah, I haven't played with this, with the output size and all that. You can probably fix it. Anyway, you either want more or less. Now, this is the fall off. So if there is a height, as you can see over here, wherever there is a branch, all the convexities goes inside and they leave from the other way. So this is why we need this shadow type. Let's call it shadow. It's not entirely shadow. And we're going to blend this together again because we're going to use this also on our height map. Okay, we're going to blend them with max lighten and use one of these. Now, and this is our wooden branches. Let's go into our sandbags before we see microsurface and all that. For the sandbags, I started again with a gradient linear 2 and a gradient linear 2, but only rotated. Okay, you can add the transform, you can add anything you want and do this. We basically need two gradients like this, and before we actually multiply them together to get this one, we're going to get width 2, and we're going to multiply it on top of the vertical or the horizontal gradient, and then we're going to blend them. So what this gives us is this nice pattern on a shape that looks like this. We're going to get a transformation to D somewhere over here. We've disabled the tiling, and I'm going to make it to slightly touch like this, because you know, on a sandbag, gravity and all that, they probably, you know, the major part of the convexity is going to be towards where the gravity is. Okay, so that means the lower side. And then I'm going to get again a gradient linear 1, this time this way. I'm going to run it through a gradient map that's also grayscale to fix, and then I'm going to multiply it, and with the values we have over here, I'm pretty much control the output of this, of the area down here. Okay, how much it pops out. But of course, this one we still want to have the convexity, so this is also grayscaled, or it's gradient goes outside, and we have the, you know, the position closest to us is this one. Now we're going to use a gradient directional warp. You can see that I have intensity pretty high and the warp angle something like this, and we're going to use a paraboloid because we want to have basically a curve type over here, and we're going to do it again from the other side, or you can also change the directional warp, it won't matter. I'm going to use a safe transformation grayscale to basically add symmetry on the X, so it rotates it around, and we're going to blend them together with max lighten, and we get something that looks like this. Okay, so we have basically the convexity, so it looks a little bit deflated over here, so you have more sand that's sitting towards where the gravity should be. And because you see, you know, some seam lines on sandbags, we're going to do again a one line. We're going to get gradient linear 2 this time, or obviously you can just simply do this. Okay, and yeah, this one is tiled, so I'm going to go over here, although, you know, this doesn't exactly look that bad, so but I'm going to simply disable tiling. Okay, just like that. Let's delete that. We can also do the same with this one, so it's a little bit more performant because it's already pretty heavy, I believe, substance. So what I'm doing over here, okay, we have a line that basically is a straight line at this point that is like this, and we're going to create, we're going to directional warp it, gradient linear 1. Okay, it's rotated this way. Add a gradient map. You can see the values I have over here, and we want something that looks like this. Okay, and this will be the seam that goes, around the convexity of the actual sandbag. I'm going to eyeball it with transformation 2D and place it, towards where the bottom of the sandbag should be. And I'm blending it with, I'm blending it with the gradient we have over here because I want to darken the edges since they are supposed to go towards, to follow basically the convexity of the sandbag. Okay, it doesn't have to be entirely perfect, but yeah, I think it sells a little bit, it sells the illusion pretty nice at this point. Now, okay, we have this, we have our basic design, so we're blending them together with max lighten on top of our design. With the opacity we can control how this will pop up. You pretty much only want to have around similar values. Okay, then we're going to tile it, and we're going to use a tile sampler. And the tile sampler can take a few maps, which can help you, distort this a little bit, or place them or rotate them or place them anywhere else. So I'm going to create an isotropic noise. You can see the X amount I do not want anything, and we want the Y amount something like looks like this. You might want to roughly, although it's not entirely needed, to roughly mimic the amount you have over here, although it still won't really matter as much, and you can play with this. We have our tile sampler. You can see 4.9 pattern input. I'm only covering the important stuff. Okay, play with the size random, scale. You usually do not want to go way too different with all of this. And for the position, you can see the displacement map intensity if you change this. Okay, it's going to displace your pattern based on what you have on the displacement map. And you can do a lot more stuff with a tile sampler that you will usually do with a tile generator, so it has its uses. Alternatively, you can simply just use the tile generator, okay, as we were doing every time, a lot of times before. I'm going to use a slow brew grayscale because we always use a slow brew grayscale, and use a pale noise zoom. Okay, you can see it's very little intensity, so that it breaks a little bit apart. The patterns make some shadowy areas and stuff like that, which I think it's nice. And then we're going to use a directional warp, and for the directional warp we pretty much want to change this and have convexities wherever there is a branch. Okay, you can, not over here, it's over here. You can somewhat see it, okay, that where it starts to get warped. So we're going to get from our wooden branches the shadow we have over here, because this is going to be applied on the warping of the base image. Okay, and I'm doing over here, I want to basically pop up a little bit the shapes, because you also have some areas like this. Although even if the pattern breaks away, it's not that visible, so we're going to cheat a little bit and add a little bit of shadows. Okay, like from this you can tell it's separate, or it could have been a little bit more. So I'm basically just trying to get the areas we have over here, and we have it as black, the dark areas. We're going to invert it. We're going to assign it with the levels, and we're going to basically subtract it just a little bit on top of your image. It doesn't matter. Okay, so basically we have our background and our wooden branches. So everything else is about getting, adding the microsurface, color, and all that. Now, Sandbag's cut and sand is basically these little areas where there's holes on the sandbags and you can see the sand behind. Okay, obviously the sand is not just sand, sometimes it's settled sand and stuff like that. Okay, we won't care about that, let's just do it. So what I did over here, I'm basically creating, I'm trying to create a few masks to place this, randomly. So I get a clouds tool, levels node, directional warp, and I'm using the directional warp towards down so that it kind of looks like the holes conform with gravity. Okay, so we use this. We're going to create another this is going to be the holes, but we're going to create also a mask, so we do not want them to be applied everywhere, and we're blending. This comes from over here because we also want to conform with so for example it kinda conforms if we look it towards the side. Okay, it kinda also takes the grayscale of whatever the sandbag has. So I'm multiplying first to get the grayscale values from the sandbag, and then I'm going to go and subtract it on top of it. Okay, and you'll get, although yeah, it's really hard to see, Substance can actually see, the machine can actually see the different values. Okay, it can see that this is not the same as this, so it will conform it. The shader will work it just fine. Now, and okay, we use the mask where we assign it, and then what I did over here is I'm going to use divide from this and this, and it will basically divide the areas, and you also have a mask for when we want to color it. We're going to invert the grayscale, and here is our actual mask when we're going to go and place our color. Okay, so this is our where we are with the holes. We're going to create just a basic sum, so we're using dirt1 levels, to pop things up, and I'm going to use a fractal sum base, sharpen, and we're going to blend it on top, so we also get a little bit more interesting color. Although, yeah, this might not be that. At first, I had the holes bigger, but it didn't make for that nice effect. Okay, we're talking about about these small areas, so if you want to skip it, just skip it. And we have our sand. We're going to add it on the base, again on the base grayscale we have over here, because again we want this to conform with the grayscale you have with the sandbag, so it looks like it follows the convexities, even though it doesn't have to be entirely the same. We're just going to do it, and we're going to use a histogram range because it's going to control the position of the sand, and then we're going to come over here and blend it with our Heitman. However, we're going to create a sand mask. As you can see from the invert grayscale, we have the actual mask we're going to use, and we're also going to use we're going to warp a little bit the holes with using anisotropic, just an anisotropic noise, just so that it conforms. Gravity is a big factor at this. Okay, it's not, because if you have a hole like this, okay, this area over here, there's no reason why it should stay up. There's gravity, so it should be the opposite way, and that kind of turned pornographic anyway. So okay, directional warp, we're going to create the mask. You can see what the directional warp did, so it looks like slices and stuff like that. And again, finally, we're going to blend it with copy. We're going to put sand basically wherever we have holes. Okay, simple as that. And we're going to add a little bit more damage on top of our sandbag. So we have black and white spots 1. We have levels, directional warp. Again, with anisotropic noise, obviously you can use the same one. And then we are simply subtracting on top of our base pattern, and you can see where it does. Obviously you can go more sublime or more extreme. I'm going to leave that entirely up to you. Okay, so basically this is the final height output. Not the final height output, as far as the sandbags are concerned. And we have to worry, you know, we also, since we are here, we're going to create the color for the sand. So basically just run a gradient over here, color from the fractal sand base, from over this, and we're going to get this just because I want it white color basically. Okay, and we're going to use add linear dots, have stuff like that. From the sand mask we're going to get this, conform it a little bit with the levels node. You can see it's very subtle, but it does so on the final image. Okay, turn that into gradient map and then subtract it on top of the color we have over here, and it's ready to be added later on our color. Now, okay, we were over here, we have our height for the background, which is this. Then we simply need to go and add the height for the branches. So we're going to subtract, again we're going to go back and we're going to subtract this value, which is the branch on the very center and the offset. We're going to subtract it, the fall off, not the offset. We're going to subtract it first on the pattern, as you can see over here, and then we're going to add it on top of it with max lighten. Now you will say, why you're doing this? And you're probably going to be right about that, although I think it just works a little bit, yeah, the fall off is much greater this way. Okay, because the max lighten will not affect any of the values over here. So what this does is basically conforms the fall off. Okay, so then we're going to use max lighten, so the branches will basically have a position to sit, and we're outputting it on the height. And we can add a little bit of microsurface on top of this one, but not too extreme. So we're going to use, and we're going to create the wooden branches microsurface. We're going to get a fractal sand base, and we're going to get fluid. Okay, this is going to be a pretty basic bark texture, but yeah, it worked nice on the final one. We're going to use transformation 2D and, you know, rotate it, squeeze it, do whatever you want with this, and we're going to blend it with an overlay. It won't show that much, but you can see it right when you're up close to each other, and we're going to multiply over our branches. We're going to use an auto levels, so it levels it levels the levels and gets all the nice values, so it kind of interpolates. You can see that it starts popping out the values, so it's like normalizing it. Okay, and then we're going to assign it with copy using this mask again, although we could just use this mask. Let's see if this will do any changes. Yeah, this is a little bit more extreme, so we're going to use that one. Okay, so it basically comes and places the microsurface detail for the wooden branches on top of the branches only. Okay, and we have something that looks like this, and we're going to add, just for the fun of it, and why not, okay, we're going to add some mud on the bottom. Since this is a wall, it works like, you know, selling the illusion that this is also a wall. So yeah, gradient linear 1, histogram scan to control the height. We're going to blur it so it's not that extreme change of values. Then we have their gradient. We're going to multiply it with the gradient linear we have over here. We almost have our value. Well, we actually do have our value. and we're going to use max lighten and add it on top of our base pattern. And we're also going to create a mask, so it's not really, it's just a little bit popping out the middle ones, so adding it on top of this with max lighten, so everything sits on top of that. Notice that I didn't want to have it on the actual height. Okay, so keep that in mind. If you want, you can add it, so this will wash out and they will look like they are all on the same level. But I think this works just fine as it is, because it can also look like the sandbags have got destroyed or lose some sand or something like that. I don't know, use your imagination over there. Okay, and this is basically finally our normal. So we're going to create a normal. You can say intensity to 10. I don't think you'll need more than 10. Everything looks like it's at its own place. Everything reads fine, I believe. Let's go by 20. Okay, 20 will make things pop a little bit more, but I didn't like that it started to look like scales. So we're going to use a little bit softer. Or let's go halfway. It won't matter. Okay, use whatever value you want or you feel it's best. Then we're going to use normal. Without putting other more normal, we create a curvature and ambient occlusion. We output the ambient occlusion. We're going to create a bark color, and I'm creating, you can see the dirt I'm creating over here, the dirt map, because I want to add. We do not care about the middle ones, we only care about the values we have, or the white parts we have on our bark, because it's going to work really nice into, you cannot see it exactly like this point, but it's going to help a little bit separate the bark. So what I'm doing is clouds 1, run it through a gradient from a bark, and I'm also using an HSL, lower the saturation and lightness, and I'm going to blend both of them and get something that looks like this. Okay, it might be ugly at this point because there is a lot of color information that we do not even care about. Okay, so we have bark color. Before we see the actual color for all the others, I'm also going to do another dirt map with a little bit slightly different values. Okay, however, you can use the same, you can use another, you can do whatever you want. Okay, nothing stops you. And we're going to also use this later on the roughness. Now let's go back and see the color. Now, the problem we have with this is that this is all nice, it has a nice texture, it has nice stuff like that. However, we cannot just pass it through gradient map and start adding color to it, because if we did, oops, bad idea, gradient map, okay, if we did, let's run it like this over here, you can see that we start getting something really groovy, and it's not what we want. However, we can cheat in this case because there is a lot of already different color values, and what we can do is basically get a base color. You can see that it's just a gray color, and I'm going to blend it with an overlay on top of clouds 3 just to get something more interesting, and I'm going to use a gradient map, and we're going to get a value like this. So this is going to be used as our color. Obviously with this we're losing everything, every information we have on, or everything we've worked so far. So what we're going to do is get this as it is, run it through a gradient map, and just leave it black and white. And with this, if you're raising it up, you can see that you can get even more darker values, and we're going to multiply it on top of the base color, so you can see that it starts conforming. We start basically get our shape back. Okay, because we're basically, you can say we've added light information to our color at this point. Okay, usually you don't want to do it like this. Okay, in PBR workflows the shadow comes from the shader and not from the texture, but this is a special case. Okay, there's a lot of information, there's a lot of small detail, so we need to cheat. Okay, so yeah, we have a color formation. Obviously this will darken everything else, so what I'm going to do again is go back from this one, running through an ambient occlusion node, even though you're not really supposed to be doing it like this. Doesn't matter, we're going to play dangerously, so we're going to use as an ambient occlusion, and we're going to create a dirt node. From that we're going to invert the grayscale, so we have the opposite of the dirt, and we're going to blend it with add sub on top of a white, or we are simply going to add a white color on top of the design we have over here, and we get something that looks like this. Okay, and this will basically, adding it with max lighting, we start highlighting some of the sandbags, as you can see, so we get even more color differentiation between them. Obviously this needs a little bit of work, and again all this is, you can do whatever you want over here, it's just coloring, it doesn't matter, we're just doing randomly stuff and trying to get a nice happy accident, as the saying goes. Now we're going to add a few spots. Grunge map 004. Okay, run through gradient map, nothing specific, multiply on top of it, you get even more colors. And back over here I'm using the sand mask. Okay, here's where we add the actual sand color, you can see it over here and over here. Okay, this looks exactly like we want it to. And then we're going to add shadows again, because we want to separate some of the stuff, and I just figured that, you know, probably if there's any shadows, they're going to be from above at this point. Obviously this is cheating again. We're going to invert that grayscale. We have to run it to turn it into color from grayscale, and we're going to just subtract it just a little bit on top of everything. And after that we're going to add our bark we have, okay, with our bark color and all that, and it started to get shape, as you can see. We're going to add the height, the dirt, okay, on the bottom. We're going to add this is the dirt. We're going to add a little bit more dirt, just a little bit, because you can see it's already too dark, which we do not want. And we're going to use a huge saturation lightness to raise it just a touch, a little bit. Okay, so you can see that there's a lot of black spots, but we're going to utilize there, we're going to utilize the roughness map, so it's going to control if they are dark, or you know how this looks based on the roughness. Okay, so this was a big one. We've seen all this. Now let's see the final one, which is basically the roughness. So what I did, I wanted to start with a base. Again, you can do everything you want with this. I just get what I have from the curved smooth, running through a high pass grayscale, invert the grayscale so we get the darker areas to be white, so it's not that reflective. Okay, then I've created a few noise, directional blur, directional warp on top of it, and blend them together with min darken. There's no really any reason or logic, we just add stuff and see what I can get, if I can get something interesting, or if the final graph or the final output looks a little bit more interesting. Okay, levels. Then I'm going to take the dirt map we have over here, you can select one of these, it won't matter. Okay, conform it a little bit, add it with max lighten, so the darker edges are are less reflective, and there we go. Our roughness, obviously metallic, is it's going to be black, and we have something that looks like this. Okay, you can see that it works. It works just fine, especially concerning the amount of stuff we've added on top of it. I think we managed to come out with something that looks pretty good. Now, if we add something, if we darken this, then you will see you will start seeing some errors. Like over here, the shader starts to make some weird stuff. However, we can just simply do it, or leave it like where it was before. Okay, so basically this is it. This was the whole graph. I know it's too much, it's probably the longest video I've did. There was a lot of stuff that we've covered with the FX map, so basically I wanted to do something with the FX map, and I knew I wanted to do so, but yeah, I think doing it conceptually works better than just doing whatever. So one more thing before I go. If you want to have and make it look like this, so you see the actual, this is the rounded cube, it's not the plain high res, and you want to see the actual height, you have to go into, obviously I'm on tessellation, you need to go on the edit and change the tessellation factor. Keep in mind that this is heavily depends on your gear, okay, on your GPU. Mine can handle even more than that, but I think just 64 for me it works just fine. Depending on your machine, obviously you need to adjust this depending on on your machine. Okay, this will work for OpenGL. For IRA, you need to go, and I'm going to quickly do it and pause the rendering because I'm recording. Let's hope it doesn't crash, and it didn't. Okay, to do that on IRA, you need to go on, if you go into material, you need to set the scale high, but this will not subdivide your mesh. You need to go on scene, here's your mesh, and you need to change the subdivision. You can have parametric or length. I think length depends on the distance from vertex to vertex or something like that. Parametric will just take the quads and subdivide them, or quads or triangles or whatever they're probably quads, I don't know, I'm guessing. Okay, this is what worked for me. Obviously when you are subdividing, still depends heavily on your machine, and you might crash Substance Designer, so save. Okay, so I'm going to go back into OpenGL, and I'm going to end the video here. There was a lot of stuff. Try to understand the concept behind the FX map, because that's what I wanted to cover from this one. And in the future we're going to see a lot more stuff with the FX map, and hopefully it won't be that cumbersome as it was in this one. So hit that like, check the description for high-res renders and other stuff. If you like what I'm doing and want to see more, then your support on Patreon will be really helpful, and I'll see you next time.